Okay. In math method, the chapter differentiation, sometimes you have to do this kind of question. Okay. When they give you a graph without equation and they ask you to sketch the gradient function of those graphs. Okay. What do? Is you sketch another graph of the which is the gradient function of the original graph. Okay, and well, you have to draw a pair of axes. There is your x-axis, and your y-axis. Label it as dydx, or you can label it as function dash x. Okay, means this is the gradient graph of the original graph. Okay, now, well, if you have a straight line on there, you have to find its gradient. Okay, the gradient of this line, this part here, is a minus number. Okay, and it's going to be rise over run. The rise is from 2 to 4. The run is from -8 to -2. So it's 2 divided by -6, which is -1/3. Okay, so to draw it on your -8, okay, this is here is -2, and you have to draw a straight line because the gradient is constant from -8, from x equals to -8 to -2. The gradient is constant -1/3. So what happens? You draw a straight line there, okay, and it's -1/3. Okay. The second part of your original graph is a horizontal straight line. Well, the gradient of the horizontal straight line is 0. So what you need is to draw a line from -2 to +4. Well, it should be there, but okay. This is +4. Okay. The tricky part is the dot here. Okay. On this graph, when x equals to -2, the gradient dydx is undefined. Okay. Simply because this function here is not continuous. It's not a continuous function. So at the point of the joint, you will have to draw a big open circle. It means on your gradient graph, this point is not included. Okay, because the gradient at x equals to -2 is not defined. It is not a continuous graph. The joint is not differentiable. Okay. Now let's look at question B. Okay, question B is a typical parabola. Okay, and okay, what you have to remember is in a parabola, the differentiation of a parabola is always a straight line. Okay, the differentiation of a straight line is a constant number. The differentiation of a parabola is a straight line. So at the turning point, the gradient is 0, which is here. Okay, and at left hand side, we say the well, you can say actually the gradient is minus number, because as x increases and in the left hand side, the value y actually decreases. Okay? So I will have a minus gradient at the left hand side. However, at the right hand side, the gradient is greater than 0. So just draw a straight line. Okay? And when x is 0, the gradient is 0. Okay? Okay, that's it for question B. In question C, I have a cubic function. Okay, and the differentiation, the gradient graph of a cubic function is a parabola, and you have to sketch it without knowing what without knowing the mathematical equation of the function. Okay, so okay. Okay, let me show you how do we do that. So first thing is we know at the turning point the gradient is 0. So at the turning point when x is equal to approximately 3, okay, the gradient is 0. Okay, we just draw a dotted line here, cast the x-axis. At this point, your gradient is 0, also at this point. Okay. Now let's look at the left hand part. Okay. At the left hand part here, the gradient is greater than 0. Okay. And in the middle part there, the gradient is less than 0, because as x increases, y value decreases. Okay. At your right hand part, the gradient is greater than 0 again. So the gradient at the left hand side part, the left part, you have has to be greater than 0, and at the right hand part, it also has to be greater than 0, and here is your parabola. Okay, and in the middle, the gradient is less than 0. Okay, and here is the gradient graph of your function. Okay. Now let's look at question D. Okay. In question D, it is a continuous graph. Okay, that's what I can say, and we have a parabola from -2 to 3, and I have a straight line from -6 to 2. Okay, now let's draw the graph. Okay, x and y. So at the turning point, the gradient function is 0. Okay, and I will have a straight line like this. So okay, let's mark the turning point first, and let's start from the left hand side. I have a straight line from -6 to -2, and let me calculate the gradient of this line by hand. So I will have the gradient will be 4 divided by -4, which is -1. Okay. So from this part here, -6 to -2. Okay. The gradient is -1. Okay. From the parabola, I know the equation is y equals to x squared. Differentiate, I have 2x. Okay. At the point x equals to -2, dy dx is, well, -4. Okay, so it's -4 here.